Bismillahirrahmanirrahim. So let us review trigonometric identities. Trigonometric identities. For example, we know that sine A plus B is equal to sine A cos B plus cos A sine B. Likewise, sine A minus B is equal to sine A cos B minus cos A sine B. Similarly, for the cosine functions, cosine A plus B is equal to cosine A cosine B and minus sine A sine B, and cos A minus B is equal to cos A cos B plus sine A sine B. So these trigonometric identities are useful in calculation of various uh, functions. For example, sine omega t plus pi. If we want to calculate this value, then we can use this identity here, right? So according to this identity, it will be sine omega t and cos pi plus cos omega t and sine pi. We know that cos pi is 1 and sine pi is 0. So that will be uh, cos pi is minus 1, sorry, right? So this is minus sine omega t, and this term reduces to 0. So sine omega t plus pi is equal to this value. Likewise, we can evaluate different other functions also. For example, sine omega t minus pi is equal to will come out to be equal to sine minus sine omega t cos omega t plus pi will come out to be equal to minus cosine omega t, right? And then cos omega t minus pi comes out to be again equal to minus cos omega t, right? And this was addition of plus pi or addition of pi or minus pi, right? Then we can use same functions for uh, addition or subtraction of pi by 2, for example. So this will be cos omega t and sine omega t minus pi by 2 will be equal to minus cos omega t, right? So if you note that if you add or subtract pi, the sign is always negative, but this is not the case with pi by 2. This is plus here, and this is plus here, this is minus here, this is minus here in the case of sine. In the case of cosine, omega t plus pi by 2 is equal to minus sine omega t, and cos omega t minus pi by 2 is equal to sine omega t. So one way to memorize this is that whenever you add or subtract pi, the sign is always negative here, right? And the case of sine, we get a sine function here, and in the case of a cosine, we get a cosine function here. In the case of addition or subtraction of pi by 2, for the in the case of sine, if the sign is positive here, we get a positive here. If it's negative here, we get a negative here, and we get a cosine function here. The opposite function, I mean. In the case of cosine also, we get the opposite function and the sign is opposite to that of the one here. Another way to actually memorize this is a graphical method. So, for example, consider this graph here, this axis here. Along this axis, we take positive cosine omega t here. Along this axis here, we take plus sine omega t here. And here we have minus cosine omega t, and here we have minus sine omega t, right? So, for example, if we have sine omega t and we are adding pi to it, plus pi to it. So, sine omega t is here and we are adding plus pi here, plus pi, we end up here minus sine omega t. And if we are subtracting minus pi, right? So, sine omega t minus pi, we again end up here, right? Minus sine omega t. Likewise, for the same case of cosine also, right? We end at minus cosine omega t if we add or subtract pi. And uh, in the case of plus pi by 2, right? We have sine omega t here and we are adding pi by 2. So if we are adding, we move in this direction, right? This is addition. Addition is in this direction, right? And subtraction is in this direction, right? So omega t plus pi by 2. So this is 90 degrees plus pi by 2, we end up here. So we get a cosine omega t, right? And if we subtract minus pi by 2, so at sine omega t is here and we are subtracting pi by 2. So subtraction is in this direction. So in this direction, moving in this direction, we get here. This is minus cosine omega t. So we can use this graph also for to calculate these values. And also remember that if we want to if we want to calculate the reverse, for the reverse thing, for example, we are at cosine omega t, and what will be the equivalent function of the in the form of sine? So we are at cosine omega t, right? So we do not have plus pi by 2 here or minus pi by 2 here, so we cannot go from here now. Actually, we need to assume we need to find out the value of the sine, in which if we add or subtract pi by 2, we will arrive at cosine omega t, right? So if we are at sine omega t, you see, and if we add plus pi by 2 here, then we will get here. So cosine omega t in the form of sine will be cosine omega t in the form of sine will be sine omega t plus pi by 2, right? So again, we need to find out the equivalent function for cosine omega t, right, in the form of sine. So we need to be at sine omega t and then find out what we need to do with the add or subtract here so that we can get the cosine. So we are here at sine, and then we see that if we add plus pi by 2, then we get the cosine function here, right? So this should also be kept in mind. Moreover, this graphical form can also be used for the addition or subtraction of the sinusoids. For example, consider this: a cosine omega t plus b uh, sine omega t, right? So again, let us again draw this. This is cosine omega t, and this is sine omega t, right? So this is a cos omega t. So the a is along cos omega t. So this is a here, for example, and this is a b here, b sine omega t, right? So this is b here, and the resultant will be this here. So let's call this c, and this makes an angle theta here. This is actually minus theta here, right? So if you see, we can write it like this. This is equal to the magnitude of this c, and this is basically cos omega t and then minus theta. This is cos omega t minus theta, right? So we need to determine the value of c and theta, right? So c is equal to, if we see, this is a right angle here, so this is a and this is b here, right? So this is a square plus b square square root, and theta is equal to this is tan inverse in the form of a and b only, right? We know a and b, so in terms of a and b, theta is equal to tan inverse b over a. So this graph can also be used for the addition or subtraction of sinusoids like this as well.